everyone, welcome to the session. So in this particular session, we will talk about Masters Theorem. I hope that everyone is clearly able to see my screen on the board. Here, I just want to tell you that first of all, where this Masters Theorem is applicable. Again, this Masters Theorem is basically helps us to solve any kind of a recurrence relation. Until so far, if you guys remember, we have discussed two different methods to basically solve any recurrence relation. One is we have talked about a substitution method, and we have solved a lot of variety of questions there to see that how basically substitution method will work. After that, we have talked about a recursive tree approach. There also, we have seen that how basically we can first of all create a recursive tree, and with the help of that, how we will reach to a bigger time complexity solution. After looking into that part as well, this is the last part where I want to tell you that the recurrence relation can also be solved using a Masters Theorem, but under some constraints that you have to take care. First of all, your recurrence relation will look like this. So whenever you are trying to apply any Masters Theorem, you should take a note that your recurrence relation will be of a form like this, where we are again having a single recursive term. For example, here you can see this t of n by b is a recursive term, and here this a is some constant and b is also some constant, and f of n is some function which is, I can say, is a positive function. Now what is the constraint? As I told you that a and b are the positive constants, and the value of a should be either less than or equal to 1, or the value of b is greater than 1. Now this f of n can be represented in this form, where I am writing it as n to the power k log to the power p n. Now it depends what kind of recurrence relation will be given to you. I will for sure demonstrate you various examples with the help of which we will be able to understand all these different cases. Now this thing which I have written here, you will find in various standard books this kind of cases which they have written in their Masters Theorem. Actually, don't need to be afraid about all these cases. These are very simple. I will try to demonstrate you in such a way that you will be able to do it very much fastly. But let's try to understand what I have written here. So first of all, whenever you want to apply any recurrence relation, you need to calculate a very first thing, which is the value of log of a base b. Okay, this is the first thing that you need to evaluate. For example, if suppose I am writing 2tn by 2 plus 1 or plus 1, okay, so this is a recurrence relation that is given to you. T of n is equals to 2tn by 2 plus 1. Now in this particular case, you have to see what is the value of a. It is 2. Just try to compare this equation with the first standard equation which I have marked in green pen. Here if you will see, the value of a is 2 and the value of b is also 2. Now this is something which we are saying is f of n, right? Which we want to represent in the form of n to the power k log to the power p into n. Now because this value is 1, it simply indicates that the value of k is equals to 0 and the value of p is also equals to 0, right? We will try to understand each and everything, but as of now, try to see what I want to infer here. That what is the meaning of a, what is the meaning of p, what is the meaning of f of n, and from that f of n, how we can compute the value of k and p. I hope it's quite simple. So the very first task here is to compute the value of log of a base p. For example, for this particular recurrence relation, my value will become log of 2 base 2, which will be equal to the value as 1 here, right? Which will be equals to 1 here. Now, we need to compare the two values. One is the value of k, another one is the value of log of a base b that you have evaluated. So the second thing is that you need to compare the two values, that is log of a base b that you have evaluated and the value of k, which you will get from function f of n, which you will get from the function f of n. Now there can be three cases that you can get. Either the value that you have evaluated log of a base b is greater, or it is equal, or it is lesser. On the basis of that, we have three different cases in our Masters Theorem. The very first case, try to understand. Here in this particular case, the example which I have just shown you, The value of log of a base b is, I believe, 1. The value of k is 0. You can clearly see that this particular situation falls under the category of case number 1, where the value of log of a base b is somewhere we are getting as 1, because we are solving a recurrence relation which is saying that, so this is, you can illustrate it as example number 1, which I want to explain you. So here we are having 2t n by 2 plus 1. This is a recurrence relation that we have. The value of t of n is something like this. Now, the value of log of a base b is equals to 1, and the value of k which we have evaluated is 0. So this clearly falls under the category of case number 1. And case number 1 says that if you are falling under me, your answer should be directly big O of, or you can say theta also, big O of or theta of, let me write in the form of a big O, because we will always talk about worst case time complexity. It will be nothing but the value of log of a base b, which is nothing but is equals to order of 1. So here if you will see, what we are saying is that, so this is order of n to the power log of a base b is the final answer. This is what you can refer from here as well. So it says that, it simply says that first of all, compute the value of log of a base b, compute the value of k, just try to compare what is the relationship. Either it will be greater or lesser or equal. Accordingly, it will fall under the category of case number 1, 2 or 3. Once you will be able to get an understanding of that, if suppose here if you will see, it is falling under case number 1, where the value of log of a base b is greater than k. In this case, your answer directly should be, you can write your result directly as n to the power log of a base b, or I can say the result will be order of n, because the value of log of a base b is equals to 1 here. So that's why you will be able to get a clear-cut answer. Here if you will see the way we are doing this thing, we have seen the substitution method as well, and we can try to use substitution method here as well, right? But substitution method took a lot of time, where we are solving a lot of series. It may be GP or AP, doesn't matter. But here if you will see, there is no series that we are solving. It's just that we have to consider that in what category or in what case our question belongs to, and accordingly we have the direct answer, right? That's why it's of much use and much ease to use as comparable to other recurrence relation methods that we have solved so far. So always remember, the very first thing to keep in your head is that whenever the value of log of a base b is greater than k, your answer is directly will be order of n to the power whatsoever value you are getting as log of a base b. I hope I am making sense. If suppose I want to give you some other example in the same format, it will be suppose 4t n by 2 plus, suppose I am writing it as maybe n. Suppose this is the equation that I am giving to you. Now again, what you need to do is that, so as of now I am intentionally considering those cases which belongs to case number 1. Maybe in the next video I'll try to explain to you the case number 2 and then the case number 3. Case number 1 and case number 3 is pretty simple. Case number 2 is also very simple, but with the help of examples, maybe initially you will be very much ambiguity, but when you re-listen this video again, maybe you will be able to clearly understand the concept which I want to explain to you here. So here again, if you will see, the value of a is equals to 4, the value of b is equals to 2. Now again, what we are trying to do is that we will try to find out what is the value of log of a base b, the very first step that we have. So it will be log of 4 base 2, it will be log of 2 to the power 2, right? This can be written as 2 log 2 base 2. This is 1, so the answer is 1. Now this particular function, this is f of n, which can be written as theta of n to the power k log to the power p into n. Here clearly we can see with the help of this demonstration, the value of k is equals to 1 and the value of p is equals to 0. Clearly we can say this, right? Now here we can clearly understand that the value of this log of a base b is somehow greater than the value of k, because this value is 2 and this value is 1, right? Again, because this is falling under again the case number 1, we can directly write that it is nothing but is order of n to the power log of a base b, which is square. So here for this recurrence relation, for the second case also, for this recurrence relation, our time complexity will be order of n square. So this you can consider as the example number 2. Any example which basically falls under the category where the value of log of a base b is greater than the value of k, you can consider right like this, right? If you want to get, if you want me to explain some other example, let me try to explain one last example where I can write it as t of n, which is equals to maybe 8t n by 2 plus maybe n square. Again, here if you will try to observe, the value of a is 8, the value of b is 2, right? And this can be written as n to the power k log to the power p into n. This function can be written like this. So clearly I can say that the value of k is equals to 2 and the value of p is equals to 0. Let's try to calculate what is the value of log of a base b. It will be log of 8 base 2. This can be written as log of 2 to the power 3 base 2. It can be written as 3, we can move ahead, log of 2 base 2. Now this again can be equals to 1. So the answer is equals to 3 here. Now again if you will try to understand here, the value of log of a base b is somehow greater than the value of k for this question as well, intentionally because I am picking like that kind of example only. Here if you will observe, this value is 3 and this value is 2. That's why this relationship holds. That's why our direct answer will be n to the power log of a base b means order of n cube. This is how you can solve any kind of question. The first thing is that in Masters theorem, you have to see that whether the recurrence relation is following the above pattern or not. This one. If it is following that pattern, you have to recognize the value of a, b, k and p. 4 things you have to evaluate. Then second thing, you need to calculate what is the value of log of a base b. Once you will be able to get that value, you need to compare that value with k. As of now, we have discussed only case number 1, where I am saying that if suppose the value of log of a base b is greater than k, at that point of time, your answer is directly equals to n to the power log of a base b. I hope with the help of these 3 examples, I am making sense to everyone that how basically I am saying it will be order of n or n square or n cube, right? Directly, how am I writing? Just you have to see these cases. And in this also, just as of now, refer case number 1 because that's what I have illustrated with you all in this particular session. Let's try to take a break now. Just try to see whether you are able to get all these examples or not. I want to give you some time. Let's meet you all in my next upcoming video where I'll talk about the next case number 2, where we will deal with the 3 different cases that we have. So until that point of time, you just try to grab the concept with the case number 1. It's very easy, right? I hope that I'm making sense to everyone. With this, happy learning to all. Bye-bye everyone. See you soon in the next upcoming session.